Okay, we're going to continue with section 3.2. Exercise example number 6. And again, these are similar to your homework examples, but not the same. Research has shown that approximately 1 woman in 800 carries a mutation of a particular gene. About 61% of women with this mutation develop a skin cancer. Find the probability that a randomly selected woman will carry the mutation of this gene and will develop skin cancer. Okay, again, and must need to inspire you to multiply. So carries the mutation is 1 in 800 times develop a skin cancer, 61%. We should turn that 61% into a decimal. And all we have to do, you can just enter it just like that in your calculator. 1 divided by 800. And I like to get that as a decimal. And then I multiply by the 61% as a decimal. So, and in here, if you notice, they want 4 decimal places. So in this case, we have 0.3076. So 0.0008. So this one is going to be 0.1238 because the 7 was followed by a 6. That's your final answer. Okay, number 7. Again, there are only 10 questions in this section. Okay, number 7, it has 3 parts. In a sample of 900 US adults, 190 think that most celebrities are good role models. 2 US adults are selected from this sample and without replacement. Complete parts A through C. Keyword, without replacement. So let's look. I highly recommend that it's not giving us a table. So the probability of being a good role model, a good role, is going to be, let me write it here, good role model. A good role model is going to be 190 over the 900. So the probability of not being a good role model. So I find that, I don't know if they're going to ask me for that, but I like to find both because they have to add up to 100. So I will say, okay, 190 divided by 900. That gives me 0.211, and they want decimal. So this is okay to say, oh, okay, so this is 0.211. So if I want to know, oh, not a good role model, so 1 minus 0.211, that gives you 0.789. Okay. So now we read it, but I recommend to do that. And again, this was 0.211. Let me clarify this number here. 0.211. Okay, so find the probability that both, remember that they said 2 US adults. 2 adults. Okay. Find the probability that both adults think most celebrities are good role models. Both adults. So what that means is that the first one is a good role. The first one thinks that it is a good role model. And the second one thinks that it's a good role model. So there is the and. The and is not always stated. It can be implied. So if both of them think that they're good role models, all we have to do, this is going to be as a fraction. We can do 190 over 900. And then the second one, since they both think that they're good role models, this is not going to, we're not going to have 190 in the next one because one already answered. So this is going to be 189 over 899. So this is going to be, and I recommend that you enter it just like that in your calculator. Open parentheses 190 divided by 900 multiplied by 189 divided by 899. Again, I subtracted 1 because it says without replacement at the beginning of the exercise. So this is 0.044. So this is going to be 0.044 because they want 3 decimal places. Okay, so that's where it came from. Again, we subtract 1 from the second selection because it is without replacement. Find the probability that neither adult thinks most celebrities are good role models. The first one doesn't think it's a good role model, and nor does the second one think that it's a good role model. So both of them saying that they're not good role models. So what that means is if 190, something that might benefit, so 900 minus 190 is the amount in terms of a fraction. Let me turn this into a fraction. This part is 190 over 900. Okay, no, 190 is 710. 710. Listen to Diego. 710. So 190 out of 900 think that they're good role models, and 710 out of 900 thinks that they're not a good role model. It's the same thing as the decimal, but in terms of without replacement, we should use fractions. So the first one out of the ones that think that is not a good role model is 710 out of 900, and the second one also. So this is going to be 709 over 899. Again, both of them think that they are not good role models. So now it goes 710, go down 1, 900, go down 1. We'll follow the same process, and you enter it in your calculator and close in parentheses 710 divided by 900, and then multiply by 709 divided by 899. That gives you 0.622. So this is 0.622. Okay, part C. Find the probability that at least one of the two adults thinks most celebrities are good role models. Okay, this part tends to be a challenging one to digest, part C. It says, find the probability that at least one of the two adults thinks most celebrities are good role models. So, it could be like the first one, they both think that they're good role models. It could be that the first one thinks that it's a good role model and the second one doesn't think that it's a good role model. It could be that the first one thinks that it's not a good role model and the second one thinks that it is a good role model. So there are 3 possibilities in terms of at least one. But the best way, this is one of those cases that you need to use the complement. So the complement of at least one is 1 minus the probability of none. At least one means 1 minus the probability of none of the adults think that it is a good role model. So this is what we're going to do. 1 minus your previous answer, because the previous answer, the one on part B, it is the one that is none. So 1 minus the adults, the probability of the adults thinking that none of them are good role models, will give me the at least one. So at least one is equivalent to 1 minus none. So in this case, this will give you 0.378. Again, this is a challenging concept to get, and one that we tend to get confused a lot in this section. Number 8. The probability that a person in the United States has type B plus blood is 10%. 4 unrelated people in the United States are selected at random. Okay, so they're selecting 4. So the probability of B plus blood is 10%. That is the same thing as 0.10. Okay, that's what is given. Find the probability that all 4 have B plus blood. B positive, I should say, B positive. So, I like that, B positive. So that means that the first one has B positive, and the second one has B positive, and the third has B positive, and the fourth, because they're choosing 4 unrelated people. So the probability of each one of them having B positive is 0.10, 0.10, 0.10. So you multiply all that in your calculator, 0.10 times 0.10 times 0.10 times 0.10. This is equal to 0.00010. And how many decimal places do they want? They want 6. So let's give them 6 decimal places, 0.123, 1 and 2 zeros. Okay? If it says 6 decimals and you didn't get 6, just make sure that you fill in the rest with zeros. Okay, so that's your final answer. Find the probability that none of the 4 have type B positive blood. So if the probability of being B positive is 10%, the probability of no B positive is going to be 0.90. Okay, because that's the complement. So none of them, none of the 4, 1, no, 2, no, and 3, no, and the 4th one, no. So this is going to be 0.90, 0.90, 0.90, 0.90. So this is 0.90 times 0.90 times 0.90 times 0.90. Okie dokie. So clear. 0.90 times 0.90 times 0.90 times 0.90 equals. So 0.65610. Those are the decimal points that I have. So let's see how many decimal places. They want 3 decimal places on this one. So this is equal to 0.656. That's your final answer. Okay. Notice that before was 6. Now this one is 3. You have to pay attention or drink some coffee. Drink something that brings your energy up. C. Find the probability that at least one of the 4 has type B positive blood. At least one, okay, remember what I mentioned before. At least one is the same thing as 1 minus none. So I'm going to use that concept, 1 minus none. That was the answer that we got before, 0.656. None of them were B positive. So 1 minus 0.656, it will give you 0.344. Okay, 0.344. Part D. Which of the events can be considered unusual? So again, they're going to be unusual when they're less than or equal to 0.05. So the event in part A, this event in part A, that was 0.123100, this is less than 0.05. So therefore, event A, or part A, I'm sorry, can be considered an unusual event. Number 9. Let me stop on number 9 and we'll work on number 9 in the next video. So we're going to stop the video here.